Okay, I've been asked to look at some questions from yesterday's homework, which was on page 308. And what we wanted to look at was the ones where you write the equation, because you have to find A. So you have a particular one you'd like? Okay, we had an example, which you're supposed to first find the vertex. So 8, I don't want to do that. Okay, so the H value, you know the vertex is right there. Okay, so H is 6 and K is 1. And then you use this as a point that's on the parabola to find A. So you write it, what the direction said on the notes was to write it in a vertex form with an A in it. Put in the vertex. Okay, then substitute in a point on the parabola. The y part is 10, so you put 10 in here. Put in 7 for the x, and then you solve it for A. So subtract 1 from both sides. 7 minus 6 is 1. 1 squared is 1, so it's just 1A. So A is 9. Okay, so then you just plop A in, and you say the equation would be y equals 9 times 7, oops, not 7, you put the x back in there, times x minus 6 quantity squared plus 1. Okay, so does someone have another one they want me to do? Julian? Okay, 39. Doing the same process as I just did to find A. First, I'm putting in the vertex, which the x part's a 0, the y part's a 5, or the k value's a 5, h is 0, k is 5. Now I'm going to put in the point, 3, 8. So 8 goes in for y, 3 goes in for x, and then solve for A. So 8 equals 3 minus 0 is 3. 3 squared is 9. So I got 9A plus 5. Subtract 5. Divide by 9. So A is 1/3. Okay, you need to reduce it, of course. And then your equation is going to be y equals 1/3 x. Well, you don't even have to put in the parentheses because it's just x squared, because there's no, the h value is 0, and then plus 5. Okay, did anybody have something else on the homework from last night? Yes, 741. Write each function in vertex form, then identify the vertex, the axis symmetry. That's actually we did for a few days, except that these were not set with y equals form yet. So you want to get it that way. So I'm just going to start with y equals. This is vertex form, y equals a times x minus h quantity squared plus k. So you're going to have to complete the square. So you got 3x squared minus 4x plus 2. So now it looks like problems we did the previous day. And this was kind of the harder kind because the leading coefficient on x squared is not 1. So you have to factor it out. Yes. Did I put plus 2? Oops, thank you. So I didn't do that. Keep going with that. Thanks. Don't know how I did that. Of course it is minus 2. All right. This is not a perfect square trinomial, so I have to do what I'm about to do. I'm dividing by 3. Okay, if I could get my pen to write. So I have to write 4/3 here because I took out a 3, right? And now I'm going to put in my blank. Then I've got minus 2. Now, I'm adding on something here, but I'm also multiplying it by 3 because of the parentheses. So I have to subtract that same amount, which is 3 times blank. Oh, come here, pen. All right, now I got to figure out what to put in the blanks. What is half of 4/3? Well, half of 4 is 2, so 2/3. 2/3 squared goes here. This one's a pretty tough one. So I got to put 2/3 squared here, which is 4/9. So I'm going ahead and squaring it. All right, now I can factor this perfect square trinomial to x minus 2/3 quantity squared. And then I got to figure out what this is. So negative 2 minus 3 goes into 9 3 times. That's going to be minus 4/3. So I got negative 2 and 4/3. I could rewrite that as an improper fraction. That would be negative 10/3. And now it's in vertex form. So the vertex is at 2/3, negative 10/3. The axis is x equals 2/3. And this thing opens up. Those are the 3 answers. That was probably the worst one, actually, so good question. I'm going to pause a minute. 48 says to write an equation for a parabola that has been translated, compressed, and reflected in the x-axis. Okay, so translated means shifted left to right, up or down. Okay, compressed makes it wider. So what kind of number would A be? Okay, so A has to be a fraction between 0 and 1. Okay, if it's reflected in the x-axis, what else do you know? A has to be negative to get it to flip. Okay, and then translated, you want to put in an H and a K. So make up your own. Could you make up your own now? All right, y equals, you're going to put in a fraction for A. I'm hoping you'll pick something other than what I was going to write. 4/3 wouldn't be any good. How come? Because over 1. Okay, so you want something smaller than 1. You have 1/3, 1/4, 1/8, but it's got to be negative because a fraction compresses it. Okay, reflecting the x-axis, it has to be a negative A value, and then you can pick any numbers you want for H and K. I think that's enough to get you to write one, right? All right, that's enough about the homework, I think. The answer to 51, you know what it is? Yes or no? If you put a 0 in here for A, come on, somebody's got to know the answer to 51. What do you think? If you put 0 in here, what are you going to get? Yep, that would be 0. So it'd be y equals K. What kind of line is a y equals a constant? Horizontal. Okay, if you put a 0 in here for A, you're still going to have this left, right? That's going to result in a line that's not horizontal. All right, so they're not going to be the same. One's a horizontal line, one's an oblique line. Oblique just means that it slants. Okay, they're both linear, but one's horizontal and one's oblique. So they will not give you the same answer because you would have bx plus c left over in the second one. Whereas in the first one, you would have just a y equals a constant. Okay. Okay, today we're doing the quadratic formula, section 5.6. It can be used to solve any quadratic. And you will be saying it over and over so many times in your head, you're going to memorize it. You have to memorize it. Okay, a, b, and c are the real numbers. We've already seen the format, right? ax squared plus bx plus c. We've already identified a, b, and c before. You can find the x, which are the x-intercepts, by using the quadratic formula that says the opposite of b plus or minus the square root of b squared minus 4a times a times c all over 2 times a. You just have to practice it. Remember, like everything else that I say. Remember that you must apply the quadratic formula to a quadratic equation. You must write the equation in standard form. So it's got to be in this form so you can see the proper values for a, b, and c. All right, so there's your quadratic formula that you need to memorize. Keep on saying the same thing. All right. Solve using the quadratic formula, give exact answers only in simplified form. That means radical form. That's why we've already practiced radicals. So for this problem, a is a 2, b is a 1, and c is a -5. You memorize the formula and you say, well, x could be, the opposite of b would be -1, plus or minus the square root of, b squared would be 1 squared, minus 4, times a, which is 2, times c, which is -5. That is going to be all over 2 times your a value, which is 2 times 2. Okay. We're going to start simplifying. The part under the radical I will bring up right now is called the discriminant. The discriminant is b squared minus 4 times a times c. If the discriminant or the number under here is positive, then you have real solutions. If the number that you get under here is negative, we're going to have imaginary solutions because we'll be taking the square root of a negative. If the number over here is 0, there's only one solution. No, a is a 2. So I'm going to figure out this part. So if you want to just type that on your calculator, I'm not going to type it. I am going to do it in my head. 1 squared minus 4 times, well, 4 times 5 is 20, times 2, that'd be 40. This is going to be plus 40 because you have a negative and a negative. So this should be 41. And then on the bottom we have 4. You can't do anything else. You can't simplify this. There's no number, perfect square number that divides into 41. So this is the answer. And that is 2 answers. You don't need to separate them. I will take it just like this. Done. Now, not all of them are done at that stage, okay? So we have to simplify as much as we can. This one is finished. On number 2, the a value is 4, the b value is 1, and the c value is -3. So we start the formula with, again, the opposite of b would be -1 plus or minus the square root of 1 squared minus 4 times -3. The denominator, 2 times 4. Evaluate what's underneath the radical. 1 squared minus, that's 16 times 3, 48 would be plus 48. So we're getting 49 on there. And on the bottom, we're getting 2 times 4, which is 8. We have more work to do because we do know the square root of 49. We have -1 plus or minus 7 over 8. And these are x values. So x is going to equal, now we have to finish off the 2 solutions. So we have to do -1 plus 7, which is 6, over 8. 6/8 reduces to 3/4. And the other value, -1 minus 7 is -8, divided by 8 is -1. So the solutions or intercepts or zeros or roots, all those mean the same thing, are 3/4 and -1. Okay, number 3, we need to get it in the proper form. So first we want to set it to 0. So we got 3x squared plus 8x minus 35 equals 0. Okay, I got some big numbers now. We got a is 3, b is 8, and c is -35. Formula starts out the opposite of b, so negative 8 plus or minus the square root of. B squared will be 8 squared minus 4 times 3 times negative 35. I think I'm going to use the calculator this time for the part under the radical. So I've got 2 times 3 on the bottom. Okay, let's find out what we got under the radical. So, oops, I want my calculator. What is that? Just negative 12 times negative 35. And that should be a positive. Got 420. Yes? Oh, wait a minute. 64 plus 420, is it 485? What is it? 484? Thanks. Okay, now we got to simplify that. Check if it's a perfect square. Second, x square root of 484. I think it is a perfect square. 29 or something. I don't remember. 22. 20. 22. So we got negative 8 plus or minus 22 over 6. So we want to do negative 8 plus 22. And that would be 14 over 6, which reduces to 7/3. And negative 8 minus 22 would be negative 30 divided by 6, gives us negative 5. So those would be the x-intercepts for that parabola. Anybody still need this page? All right, we'll practice some more. This one's already set up to 0, so I see A is a 1, B is 4, C is negative 14. Opposite of B, negative 4 plus or minus square root of. B squared, 4 squared would be 16, if you feel like doing that right away. 4 times 1 times negative 14. And that's all over 2 times 1. 16 plus 56, 66, 72. And that's all over 2. All right, now 72 has a perfect square that divides into it. What's the biggest one? Not 9. 36. Okay. So we need to break that down. 36 times 2 is 72. Always want to check if you cut it in half, if that's a perfect square number. All right, now we have more to work to do because we're going to take the square root of the 36, bring it out. That's 6 root 2. And that's all over 2. Now, I hope maybe you'll have an understanding now why I liked you to put your number before the plus or minus part, okay, when I was showing you how to solve by square roots. And that was also kind of getting you ready for this. We can divide by 2. Now, what can you divide by 2? And what do you have to be able to divide by 2 in order to simplify this? If this wasn't an even number, we would be done. You cannot just do this, okay? It has to be everybody outside divisible by a common factor. So since 4, negative 4, and 6 are divisible by 2, we can reduce this to negative 2 plus or minus 3 times the square root of 2. Now it's done. Okay, are we ready for 5? I do need to wait a second. Please look at number 5 and think about what I've said to you over and over about factoring. What's the first step? Yep, you can divide everything by 3. So I'm going to divide that whole equation by 3 because it's going to reduce it down to x squared plus 3x minus 9 equals 0. You divided 0 by 3 also. Now, I want to make a point as to why you can do this. If you were to graph this parabola, it would be a narrow parabola because a is 3. This is just the same it has the same answers for its x-intercepts, but it's not narrow, it's normal width. It's not affecting the x-intercepts to have divided by 3. This one would look different than this one because of the width of it. But it's okay to do this because the x-intercepts are what we're interested in finding. So now A we would use as 1, B is 3, and C is negative 9. So we go the opposite of B would be negative 3 plus or minus the square root of. B squared would be 9 minus 4 times 1 times negative 9 all over 2 times 1. We get negative 3 plus or minus 9 plus 36 is 45. Square root of 45 can be simplified. On the bottom we get 2. We break apart the square root of 45 to 9 times 5. We take the square root of 9 and bring it out. 3 root 5. And that's all over 2. There are no numbers. We can't divide by anything. 2 does not go into the negative 3 or the 3, so we're done. So those would be the two x values. And of course, these do equal x, by the way. Okay. Are we good with 5? Okay. Number 6, we need to rearrange 6x squared minus 2x and add 25 to both sides to get it set to 0. They must be set to 0 to use the quadratic formula. Try to add 25. So I've got an a of 7, a b of negative 2, and a c of 25. This time the opposite of b will be positive 2 plus or minus. One trap right here, guys, do squaring negative 2 in your head. What is any number squared going to be? Positive. Okay, so what I want you to realize is this always will be a positive number coming next, okay? So negative 2 times negative 2 in our heads. We'll just write 4 instead of making the mistake of trying to type that in the calculator and forgetting to put parentheses. Okay, minus 4 times a is 7 times c is 25. Uh-oh. I see a negative number coming. And the bottom is 2 times 7. Okay, 2 plus or minus the square root of. I'll go ahead and grab the calculator. So that's going to be 4 minus 4 times 7 times 25. And I get negative 696. I just want to check if 696 is a perfect square. Nope. Ew. What does 696 divide by? I have the right number, right? Okay. I'm going to try dividing by 9. I don't know. It just looks like it might work. Nope. What's half of that? Oh, I can divide that by 2. So I know there's a 4 in there. Oh, let me see if there's another 4 in there. I'm prime factoring it. No. Okay, so it looks like 4 times 174, 87 prime. Okay. I know we had negative 696 though, right? Okay, so we've got, I broke it down into negative 4 times 174, and the bottom's 14. I can take the square root of the negative 4, it's 2i. And then I got times the square root of 174, all over 14. All of these guys are even. So we can divide by 2, but don't make this one disappear. 2 divided by 2 isn't 0, it's 1. So we got to have 1 plus or minus I times the square root of 174 all over 7. Okay? Finally got one with an I answered. Now I'm going to talk to you about the discriminant. I already mentioned this earlier. If b squared minus 4ac, remember that's just the part underneath the radical. You're going to need to know this, and it's one thing that's easy. It's just that you guys are going to forget it because you didn't, I don't know. I just find that people usually forget this one on the next quiz. Okay, when we talk about the discriminant. What was that thing again? All right, so the point is, if the stuff, remember where that is? It's underneath the radical, right? You're only doing this part, and you're checking if it's positive, then you have 2 real solutions. If the number under here is 0, then you only have 1 real solution. And if the number under here is negative, less than 0, then you have no real solutions. They're imaginary. That's when we get the I answers. Okay? That's all you need to know about that. So it says find the discriminant and determine the number of real solutions. So all we're finding is b squared minus 4ac. b is a 6. 6 minus 4 times 1 times 3. So we go 36 minus 12 is 24. You tell me the discriminant's 24. That means it has 2 real solutions. And that's all it's asking. Okay, so b squared in this next problem, 10 times 10 is 100. Doesn't matter that it's negative because when we multiply it times itself, you get a positive. 4 times 1 times 34. I can tell right now this is going to be negative. Minus, what's that, 120, 136. It's negative 36. And that would mean that since it's negative, there are no real solutions. If you'd like to write that there's 2 imaginary, that's what you get. That means that parabola doesn't cross the x-axis. Okay, b squared on this one's going to be 64 minus 4 times 1 times 16. 64 minus 64 is 0. And that, yep, 1 real solution. And guess what? I want to point something out. Do you see that's a perfect square trinomial? And that would factor to x plus 4 quantity squared. So what's the 1 real 0? Just by thinking about the other ways we've solved. What makes this 0? Negative 4. You remember what that means if it's a double root? I'll remind you, a double root, that would be where negative 4 is. It bounces. That's when you get a double root. It bounces off the x-axis and just has that 1 real solution. I just keep bringing it up because we're going to need to know it later. Okay, so then we already, these aren't the same problems, are they? No. It's just more of them. Okay. So equals 0 means 1 real. Greater than 0 means 2 real. Less than 0 means no real or 2 imaginary. And the discriminant is b squared minus 4 times a times c. Why don't you try these 3? And then we'll check them. I want to make sure you understand the entire problem. So if you're just doing the discriminant, you should have found out that you get -4, which means there are no real solutions. Now that you found the discriminant, we want to do the whole quadratic formula. So the opposite of b would be -6 plus or minus the square root of what we got for the discriminant, which was -4, all over 2 times a, which would be 2 times 1, and that's 2. You get, and remember, these are called the solutions, the x-intercepts, the root, the zeros. All of those mean the same thing. So if I simplify this thing, I get -6 plus or minus 2i divided by 2. And then the final answers would be -3 plus or minus I, because everything's divisible by 2. I said to solve giving the exact solutions. So first, let's do the discriminant. B squared would be 25 minus 4 times A is 1 times C is -5. That's 25 plus 20, so we get 45 for the discriminant, which means it has 2 real solutions. To find those solutions for x, we will do the opposite of b, which would be 5, plus or minus the square root of 45, the discriminant, all over 2 times a, which would be 2 times 1. So then we got to simplify the square root of 45. Square root of 45 is 9 times 5, so we take the square root of 9 is 3. 3 root 5, all over 2. We can't simplify that, so that would be the complete answer. We need to set number 12 to 0 first by adding 3 to both sides. The discriminant would be 49 minus 4 times 6 times 3. See, 24 times 3 is 72. 49 minus 72 is going to be negative, what's that, 23? And that's going to be no real. But to get the final answer, we'll continue the quadratic formula. The opposite of b would be -7 plus or minus I times the square root of 23. I went ahead and pulled the I out. And over 2 times 6, which would be 12. That's it for that one. Okay. Now the rest of the part on back of 22b, another thing to keep remembering, that your axis of symmetry is found by doing the opposite of b over 2a. Sounds like something in the formula, doesn't it? It's everything but the discriminant. It's the beginning of the formula. But anyway, that finds the x value of the vertex, and it also will be used when you want to find the maximum or minimum. So find the equation for the axis of symmetry and the coordinates of the vertex for each parabola, then find the x-intercepts exact values using factoring or quadratic formula. So you got options, whatever looks easiest to you. Quadratic formula will always work, completing the square would always work, and then sometimes factoring works. The axis is going to be x equals the opposite of b, which is 2, over 2a, which is 2 times 1. 2 divided by 2 is 1. So your axis is x equals 1. Okay. That is the x value of the vertex. And then we're going to plug in 1 to get the y value. Okay, so y is going to be 1 minus 2 minus 15, which is -16. Okay, it says then find the x-intercepts exact values using factoring or the quadratic formula. Can you factor this one? I see factoring as the easy part, because you can do x minus 5 times x plus 3. And that gives you 5 and negative 3. And I don't care which one's first or second. Okay. Number 14. The axis will be, I'm just going to do the opposite of b up here. So it'll be negative 1 over 2 times negative 1. So I get a positive 1/2. So the vertex is at 1/2 something. I have to do the opposite of, and I'm just going to use 0.5 squared plus 0.5 plus 6. And you can use your calculator for that if you like. It's going to be negative 0.25 plus 0.5 plus 6. That's 6.25. Okay, 6 and 0.25, if you want to rewrite it in a fraction form, you can just hit math, enter. It's going to be 25/4. All right, now finding the x-intercepts. You can factor this one. However, you'd have to factor out the negative sign. So, rather do quadratic formula maybe? Doesn't matter to me. I don't think some of you would like factoring this maybe. So maybe we should just do the quadratic formula. Okay, opposite of b would be negative 1 plus or minus the square root of b squared would be 1 minus 4 times negative 1 times 6. And then all over negative 2. That'd be 1 plus 20, be 24, square root of 25. Okay, so I've got negative 1 plus or minus 5 over negative 2. But 4 divided by negative 2 would be negative 2. Sorry, I made a mess here. The x-intercepts. 4 divided by negative 2 is negative 2. 0 is 1. And negative 1 minus 5 is negative 6. Divided by negative 2 is positive 3. All right. I've got to give you your book page on paper. Your assignment, we didn't have time to finish these problems, but I'll go ahead and do them now. Or maybe I'll wait till tomorrow. I think I'll wait till tomorrow. You do need to do the book page. I'm passing out the book page on a worksheet right now. Have a great day.